creating linear models for data, exploring transformations on linear functions. What we can see is two different trend lines, so two different graphs, y equals 2x minus 30 and y equals x. The graph of the trend line has a y-intercept of negative 30, so that is the blue line, is negative 30. The graph of the line y equals x, the blue line, has a y-intercept of 0. Both lines are increasing, so they both have positive slopes. And the trend line of y equals x is actually a lot steeper, the trend line y equals 2x minus 30 is a lot steeper than the line y equals x because the slope is bigger. So the red line is steeper because the slope is bigger. So looking here, our blue line y equals x actually has a specific name. So both of these lines are linear equations. However, y equals x is known as the parent function for all the graphs, and that's something that we're going to explore. Okay, so what we want to do is we want to explain how the rate of change or the slope of a linear function affects the graph of the function. And the rate of change determines how steep or how flat the line is compared to the parent function. So again, the parent function is blue, and then the red lines are going to be my other linear function. So the slope determines how steep they are compared to the actual original, the given, the parent graph, y equals x. So when you have a positive slope, the value causes the line to rise from left to right. And when you have a negative slope, the value makes the line fall from left to right. The slope of our parent function, y equals x, the slope is the number in front of x. Because nothing's there, it's actually 1. And that 1 is positive, so the graph rises from left to right. So the y-intercept of any linear equation indicates the number of units that the line has shifted up or down from the location of the parent function y equals x. So we're always comparing it to that. And the red dotted line, so y equals 2x, it has a slope of 2, and if you go all the way down, I hit the y-axis at 0, so the y-intercept is 0. So this indicates that it is steeper than the parent function y equals x because 2 is bigger than 1, so my dashed line is steeper. But it has not been shifted up or down. So do you see how they both start at 0? That means that their y-intercept is the same and the graph did not move up, nor did it move down. Now if we look at our next graph, this line has a y-intercept of negative 30, this dark red one. So you had to shift the graph of y equals 2x down 30 units. So if I started at 0, I went down 30 units in order to start this graph. That means that you have transformed the graph of the parent function y equals x, creating the trend line y equals 2x minus 30. So when you move something up or down, it means you have transformed the graph. So what we want to do here is we want to sketch each graph. So the first graph I need to sketch is 3x plus 1. Plus 1 indicates that I'm going to shift the graph up 1 unit because that's my y-intercept. My slope is 3, so I need to rise 1, 2, 3, and run 1. So I need to move my red point up 1, 2, 3 over 1. So what you can say is that my new line is 3 times as steep. I shifted the graph up 1 unit and the graph rises. So again, these are the 3 transformations that I would write that occurred from the parent graph to the line y equals 3x plus 1. Shift 1 unit up, 3 times steeper, and rises. So now I need to graph the line y equals 1/2 x minus 1 and see how that changed. My y-intercept is -3, so I need to move my start down 3. The 1/2 tells me that I need to go up 1, right 2 units, and check my graph. So, oops, I'm off just a little bit here. Sorry, it's hard to get exact. There we go. And what we want to do now is describe the transformation. So from the dash line down here, this time I shifted 3 units, but I went down. The graph now is only half as steep, but the graph still rises. So you can see that the dash line is steeper, the slope is bigger. So it's only half as steep, and I went down 3 units, but they're both still positive slopes, so they both still rise. Okay, so for our very last one, -3x plus 2, the y-intercept is 2, so I'm going to move the graph up 2 units. -3 means that I am going to fall 1, 2, 3 and go right 1 because I always run right. So now you guys can see that the graph has flipped. So I need to describe my transformations. So this time I shift 2 units and I went up again. Because the slope is bigger, the negative doesn't matter. It is still 3 times as steep, but this time my graph falls instead of rising. So it's hard to tell the steepness, but 3 is bigger than 1. You just ignore that negative. So what we need to do is we need to match the descriptions with each graph, and you want to compare it to the parent function y equals x. So I went ahead and labeled on your note sheet the descriptions as A, B, C, D, E, F. So make sure that you double check the right ones are there. So looking at the very first graph, I can see that this graph, if it started at 0, it shifted 1 unit down. So I want to first look for that option, which is going to be right here. And then check your slope. It has a rate of change of 2/3, which means I went up 1, 2 over 1, 2, 3. Perfect. My next graph, if I started at 0, I shifted 2 units up. So I would want to go 2 units up, and the slope actually remained the same, up 1 over 1, up 1 over 1. So that would be this one. On your paper, that is letter E. So the first one was B, the second one was E. The third one, I shifted again 2 units up. However, the slope now looks like it is 1, 2, 3 over 1. So it looks like it has a rate of change of 3. So that is going to be answer choice D on your paper. The next one now, I went from 0 up to 2. So again, I shifted 2 units up, but now I flipped it. My slope is going to be a negative number, so I fall 1, 2, and I go over 1, 2. I'd actually fall 1, run 1, fall 1, run 1, so I could do it either way. So I need a slope of -1, and I also have to shift up 1. Now, something that the way they write it is they put that you reflect it across the x-axis because it is flipping positive to negative. And that would be answer choice C. And finally, we're left with answer choice A. And you can see that instead of starting at 0, I shift the graph 6 units down. So I want to make sure that's where I start, down 6. And then I'm just going to double check. It is a positive slope, and you can see I go up 1, 2 over 3. So this is answer choice A. So it goes B, E, D, C, A. Okay, so now we have our parent function y equals x, and we need to see how f of x minus 2 compares with this. So what we want to do is actually put them on the same graph so we can see. And the red line is my new function. I started at 0, and I can see that I shifted 2 units down, okay? Or, you know what, you can also say you went 2 units to the right, okay? So it's technically going down or it's going over, and the slope is the same. They actually both have a slope of 1. So let's just say, because we know that the y-intercept is -2, we'll say that it also went 2 units to the right, and then it has the same slope, which is +1. For this last one here, we are going to just compare the first one. So the parent function f of x equals x, and now we're going to compare 3 times f of x. And we want to see, so we have to first analyze the graph. And because we have that 3 there, you can see that the graph became steeper than the parent graph by a lot. Also, the y-intercept stayed the same, which is a y-intercept of 0. So they both have a y-intercept of 0, however, my red line is now steeper, and it's actually 3 times steeper.